Okay, so we've been talking about the coordinate plane and how to plot points and where points are located and coordinates. Today we're going to talk about distance. Distance between 2 points or 2 coordinates. So for instance, the distance between A to B. The distance between 2 points is the length of the line segment that connects them. So from A to B, here's the line segment that connects it. And this is easy because there's a graph drawn, so really all you have to do is count the units. So the distance from A to B is 1, 2, 3, 4, 5. 5 units. A and B form a horizontal line. As you can see, it's going side to side. Another way you can tell, let's look at the coordinates. Let's say if you didn't have a graph and you wanted to know if the line they formed was vertical or horizontal. Well, you would look at the x and y coordinates. A and B have the same y coordinate. Horizontal lines have the same y coordinate on every point in the line. Okay, now let's say we want to find the distance between A to C. Well, once again, you could just count the units between them. 1, 2, 3, 4, 5, 6. Okay, so the distance from A to C is 1, 2, 3, 4, 5, 6 units. Now, A and C form a vertical line, a line that goes up and down. Another way you can tell that is by looking at the coordinates. Alright, I've given you the coordinates. Point A is 1, 4. And point C is 1, -2. A, C. Okay, this is a vertical line because its x coordinates are the same. And every point on a vertical line will have the same x coordinates. Okay, now let's see if we can do this. How would we do this if we didn't have a coordinate plane? How would we find the distance between 2 points if there was not a graph and you could not count units? Alright, let's see here. Okay, let's say you want to find the distance between point A, which is 1, 2, and point B, which is -3, 2. Well, first you need to decide if it's a horizontal or a vertical line. Which 2 coordinates are the same? That's the y coordinate. And if the y coordinates are the same, then these 2 points, point A and point B, form a horizontal line. Now, to find the distance of these 2 points, we're going to take the absolute value of the x coordinates. Because let's look at it this way. Look at the y coordinates. There's 2 and 2. What's the distance between 2 and 2? There is no distance. So you know you're not going to be fooling with those numbers. In fact, you know I tell you just to mark out what's the same in the same spot because you know you're not going to be messing with those. So you're focusing on -3 and 1. You're finding the distance between 1 and -3. Now there's a rule. If these 2 coordinates, point A and point B, are on the same side of an axis, then you subtract the absolute values. If they're on opposite sides of an axis, then you add the absolute values. Well, I can tell you right now that 1 and negative 3 are on opposite sides because 1 is positive and negative 3 is negative. So that tells me right now that they're on opposite sides of an axis. So I know I'm going to be adding. So I've got 1 plus negative 3. But I don't want to deal with this negative. Do you remember when I was telling you when we did the lesson about absolute value, and I told you that every absolute value of every number is going to be positive because absolute value is the distance away from 0, and you cannot have a negative distance. Well, what are we trying to find right now? The distance. So you cannot have a negative distance. I want to get rid of my negatives. Therefore, I'm going to take the absolute value of my negatives. And what's the absolute value of negative 3? It's positive 3. So what I've really got is 1 plus 3, which is 4. So there's my distance. The distance between A to B is 4 units. There's my answer. Now let's try another one. Okay, let's say point R. Let's say point R is negative 2, 5, and point S can be negative 2, 7. Okay, once again, I do not have a graph. I can't count the units to see the distance. So, let's do the short version of this. It doesn't matter if it's a horizontal or vertical line. All I want to do is find the distance of these 2 points. So, you know you're going to be crossing out negative 2 and negative 2 because what's the distance between negative 2 and negative 2? There is not a distance. So you're not going to be using those. You can cross out what you know you're not going to use. That leaves you looking at 5 and 7. Now remember your rules. If it's on the same side of the axis, you subtract. If it's on the opposite side of the axis, you add. So I'm trying to figure out if I add or subtract 5 and 7. Well, an easy way to decide if it's on the same side of an axis or the opposite side is to see if the signs are the same. Are they both positive? Are they both negative? If they are both positive or if they are both negative, then they are on the same side of an axis. In this case, they're both positive. So, what's the rule for same side of the axis? Subtract. That's what we're going to be doing right here. But you're saying, wait, Ms. Short, you can't take 7 away from 5. And you're totally right, you can't. 5 minus 7 would be negative 2. And remember, you cannot have a negative distance, so that's not right. That's not what we're doing here. You can't take 7 away from 5 and get a positive number. So, you're going to flip-flop them and say 7 minus 5. And it gets you 2 units. So the distance between point R and point S is 2 units. Alright, let's do one more. Okay, let's find the distance between U and V. Okay, let's say we've got okay, point U is negative 1, 3, and point V is negative 1, negative 4. Now, we're just finding the distance between these 2 points. I'm not asking you if it's vertical or horizontal. I just want to know the distance between point U and point V. Remember, you mark off what's the same in the same coordinate spot. So, we've got a negative 1 in both x coordinates positions. So we're marking those off because we're not fooling with those. We don't want to mess with those. We are now looking at the distance between 3 and negative 4. We've got to decide now if they're on the same side of an axis or on opposite sides of an axis. If this point is on one side of an axis and this point is on the other, or if they're on the same side of an axis. So remember your rules. If it's on the same side of the axis, they're going to have opposite signs. No, excuse me, that's wrong. They're going to have the same signs, and you're going to subtract. If they're on opposite sides of an axis, they're going to have opposite signs, and you're going to add. Okay, so here's your rule right here that you've got to remember for every 2 points. Now let's decide if 3 and negative 4 are on the same side of the axis or on opposite sides. Let's look at their signs. 3 is positive and 4 is negative. Okay, so they have opposite signs. What does it tell me to do with opposite signs when they're on opposite sides of an axis? It tells me to add. My rule tells me to add. So I've got 3 plus a negative 4. Remember what we do with our negatives. Since we cannot have a negative distance, we're getting rid of our negatives. How do you get rid of your negatives? You take the absolute value of it. That leaves me with 3 plus a positive 4, which is 7. So the distance between point U and point V is 7 units. Now, let's see. Let's remember that point U is negative 1, 3. That's this one right here. And let's remember that point V is negative 1, negative 4. It's this one right here. Alright, now we're going to see if we were right, if the distance was right. Point U was negative 1, 3, and point V was negative 1, negative 4. Okay, so let's find point U. Negative 1, 1, 2, 3. Here's U. Uh-oh. There's U. Alright, now let's find point V. Negative 1, 1, 2, 3, 4. Here's V. Let's find the distance between these 2 points now. Remember, if it's on a coordinate plane, all you have to do is count the units of your line. So here's the line that it forms. Let's count the units. 1, 2, 3, 4, 5, 6, 7. 7 units. Distance between U and V is 7 units. We did it right when we did it without the coordinate plane. Okay, so we've been talking about